inequalities, this is now lesson 20. Quadratic inequalities generally are something like quadratic equations, but they've just got an inequality sign. Now you've done inequalities before in your life. You've done linear inequalities, like for instance, 2x minus 3 is smaller than 0. How do I solve that? Take the 3 across and then divide via 2. And that's the answer. How many answers are here? A lot. Infinitely many. Because from 3 over 2, not including 3 over 2, there's a lot of them. So we always represented it on a number line. So there's 1.5 or 3 over 2, excluding, and then I knew whether you could read that this is smaller or bigger than, depending on if you did it this way or that way. What is this? Smaller than. So if you drew it to the other side, I know you don't know how to read smaller than and bigger than. How will you remember smaller than and bigger than? Okay. Smaller? Bigger? I don't care how you remember it, but remember it. Are you with me? That goes with smaller, bigger. Got it? Okay, but that's old work. There was one little twitch to it. If this had been a negative, what happened to this sum?
It changes
If you divide by negative 2, that'll be 3 over negative 2, and the negative can stand in front, that's fine. But then you swap the sign. Why? Why?
We were just
told to do it. Okay? But there's a reason why. A logical reasoning why. And I'm going to prove it to you saying something that's true. Is negative 2 smaller than 5?
No.
Yes. Okay. So then time both of those sides with a negative. Then this is positive 2 and this is? So why must the sign change? Otherwise it's not true. It's not making sense. That's the only reason. It's not mystical. The sign changes, otherwise it's not true anymore. To make it true, that's why the sign changes. Whatever you write down there for me with a that's true, if you time both sides with a negative, it won't be true anymore unless you swap the sign. That's the reason why we swap signs. Alright, but now we're getting into quadratic inequalities, and with the quadratic inequalities there's quite a few rules. So if I start off with a sum, and this is generally not what you will get in a matric paper. In a matric paper you're going to get nice easy ones, we go in there. But the first thing I'm teaching you to do when you see the inequality sign, I want you to see in the back of your mind something like this, and you don't know what I'm talking about at the moment. I'm going to explain it to you now. So I want you to see, not exponents, I'm not seeing roots, I'm not seeing all the stuff that you should focus on knowing, oh, if it's that, I must do this, if it's that, I must do this. If you see the inequality sign, from now on, in your brain, I want you to see there's some sort of a technique involving a little graphy. Just like with James Bond, little technique, all these techniques that I'm teaching you, this is a technique. But it's got a huge number of rules, which you're going to get to, but not in one day. Okay? And those rules involve a few things. First of all, I say, you must get 0 to the one-hand side. Now, our 2 examples on the board are done. Okay? Then you must factorize. Done. Because I'm helping you with the first few ones. If it's not factorized, you've got to factorize. And usually it's just a quadratic inequality, so it's a nice James Bond or common factor factorized. But then the rules are, your factors must be descending. So you can't have 3 minus x, you've got to have x minus 3. You see why I'm giving you this example. What do you do then with it? So you've got to change it to look correct. So I'm saying it must be descending, meaning that it's x to the power 1, then x to the power 0. Do you see it in descending powers of x? This one was not. It's x to the 0 first, then x to the 1. That's ascending. You hear what I'm saying? So the x must be in front. And it must be positive. That means the x must be positive. You can't have a minus there. And then you'll change it how? You'll time a negative somewhere in your equation which you now know. But times with a negative in an inequality, sign's going to change. So this whole technique I'm going to show you with that little thingy that we're going to draw there is all about the rules being met. If the rules are not met, you can go for that method and it's not going to work. It's got to be descending and it's got to be positive. No problem. They're all the x in front, so it's descending, and they're all positive, so no problem. Then I say the next step is, now find the critical values. If this had been an equation, you would have said, x is negative 2, x is 1, or x is negative 3. That would have been your equation answer. Those are now your critical values. Because it's not just going to be those answers. Remember we said if x was smaller than 3 over 2, how many answers were there? Lots. Right? That just gives you your starting point or your ending point. Those are your critical values. You're still going to do this. But we're now going to call them critical values. Because they're going to be where you'll start looking for your solutions. On a number line, on a graph, you're going to represent those critical values now. And the numbers are negative 2, 1, and negative 3. Logically on a number line, where would I start? Negative 2. Is there any sort of a scale involved here? Nothing. It's just a tool like James Bond, little pencil marking that you're doing there. Now, according to this, now guys, this comes from cubic graphs, which you only do in matric. So you won't know what I'm talking about. I'm just teaching you a technique like the little James Bond. But that's where it comes from, okay? So if I do this cubic graph, I say, find the critical values, put them on the number line, start your curve on the top right-hand side. Because I make it top right-hand side. There are other techniques where it sometimes isn't top right, and I'm not going to do that to you. You just follow the lead, okay? Top right. Then you make a curve going through all of those critical values. So you're going to go through the one and back up again and back down again. And then up to where? Infinity. And up where? Infinity. Are you with me? This is a cubic graph, by the way, for next year. So in the cubic graph, you draw them through your critical values. Now this time seems like it's taking forever, but it's going to go like that. 2 minutes, then you're done with your sum. Okay. Checking for the factors, checking that they're in the correct order, negative, etc., etc. Put them on a number line, and now we've sketched our little curve. Now, you must color in, or what do they call it? Nice word. Looking for the word. Shade. Thank you. Thank you. You shade an area. The area that you're going to be shading, it's all about the number line and the curve. I say, if the sum was a bigger than sign, you are going to be at the top of the number line between the curve and the number line. So between them would either be here, are you with me? I'll draw it a little bit longer. That's between the number line and the curve. There's nothing here. That's between the curve and the number line. That's between the curve and the number line. That's between the curve and the number line here again, up to infinity. So where must I color in for this sum? If it was, I can't remember what I put there. Say it was bigger.
No, the other.
Was it smaller?
Yes.
Thank you. Because I erased it when I made it an equal sign, smaller. So for smaller than, where do I color in? Below the number line, between the number line and the curve. So there's nothing here. It's there. Up to where? Infinity. And here? Up to where? Just there.
Yes.
And nothing else.
Yes.
That represents a solution. But there's something else switch to it. You must either include these points or not, like we did with the 3 over 2 just now. This says you've got to exclude. Exclude. So that's when you go to your critical values and you say exclude, exclude, exclude. This represents, and I didn't need much space because I'm just going to read off this answer. What is represented here? That x must be less than negative 3. X less than negative 3. That's going to be your first mark. Out of all of this, what does this represent? X must be?
Between.
How do we write between?
Isn't it equal?
Always. Always, 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 always. Between. The lesser one on the left, the bigger one on the right, so that would be negative 2 and 1. And always, in between answers, or. So it's either there or there, and both of them were also excluded. Guys, this mark, this sum is finished, and you have 3 marks. How many marks for this? Nothing. There's other techniques as well. You can go and have a look in your textbook. They show all the techniques. I'm telling you, this is the better one. And it goes quick. But you've just heard the first one. We're going to have to do a lot more. Okay, because I haven't even gotten to the last bit here. We have said, you color in, there's a represented solution that you're going to write down. There's one more thing that hasn't happened here. It's not going to happen in the next one as well. If there are 2 of the same factors, or even more of that, if there's the same factor, your graph is going to bounce. It makes no sense to you unless I show you an example. Alright, let's do the next one. Sum's done. I've got a solution. If you want to go test me, take for instance negative 4. If you take negative 4, it should make the sum work, right? If you put in a negative 4 there, and there, and there, and work out the answer, it should be less than 0. I don't know how much. Minus 10, minus 17.5, minus a million, I don't know. But it will be less than. If you take something here, like negative 2.5, it won't work. You put negative 2.5 in there, there, get the answer, timed it with each other, it will not be less than 2. Less than 0. Are you with me, everybody? And the same there, if you take 2, it won't work. Are you with me? Alright, let's go for this one. Let's go through the method. First of all, we always get it equal to 0. So the first few ones I'm helping you. If it's not 0, you make it 0. Like all of our rules for equations. Then we factorize. What does factors mean? They are multiplied with each other. What about division? Division is still a factor because division is the inverse of multiplication. So this is still factors. How many factors? There are 3 factors. Multiplied and divided by each other, 3 of them. Are they okay? According to my rules? No. Descending and positive, shop. Descending and positive, shop. Not shop. How do I change that? 2. X minus 3. And leave the x minus 2 and leave the x plus 1. Just like that. But the sign will change because of the minus that I've timed in there. Now, usually what we always do is we show the multiplication inside and we show the multiplication outside, but you now know that that minus must be gone. You can't have a minus hanging around here because that means it's not positive. Every factor must be positive, and if there's a minus 1, which is a negative factor. You can't have that. You must have it positive. So immediately I time it away and I've got a positive. So now what do I do with this method? You go write down your critical values. You're not always going to write it like that. I just want to see them on your graph. On your graph, what are your critical values? 2, negative 1. Okay, so where do I start? Negative 1. Okay, so it might be a good idea for you to write 2, negative 1, 3, and then decide in the correct order. First negative 1, then the 2, then the 3. Not according to scale. I want to make it big enough for me to see what's going on there. Even if it's 1, 1.5, 1 1/4, you don't go sketch them like this. You want to put them separate so you can see what's going on there. Okay? So, then if everything is fine according to the rules, we haven't seen a bouncy thing yet, we go to the top right hand side and we're going to curve through all of those critical values. There's not always going to be 3. Instead, actually there's always 2 in a matric paper. But
exclusions by very exceptional circumstances that you do find this, but I want to do it with you because there are higher level sums where this is going to help you. So we go to the top right hand side, we go through and through and through. Happy with that? Going on till forever, going on till forever. But this time we're going to colour in. Do we look at this?
Yeah.
Or do we look at this? You were working to get it correct. You're looking at is it bigger or smaller? Bigger than. Bigger than, where do you colour in? Above the number line. Is there anything there?
Yeah. No.
It's here, above the number line. So between the number line and the graph, the curve. So there's nothing here, but there's something here again up to where? Infinity. Now, do I include those critical values or not? This says yes, but with a twitch. With a twitch. At the moment you have a fraction. Can this be 3? If it's 3,
No.
then you're dividing by a
0.
0. The moment that you get to a fraction, that cannot be included. Although this says, include me, include me, include me. You cannot include the 3. That will be excluded for a good reason. So there will be definitely a mark for that. But the other two, they're okay. This sum said include them, and I'm including them. So if few kids will include that one, you're going to lose a mark. Because of the red lights, the 3 red lights. You cannot divide by a 0. Okay, so now there's my representation. There's your answer. Just write it down. So what's this piece? X lines? Between. So we write between -1 and 2. In and exclude? Included, or the other piece? X is bigger than or greater than 3, not included, and we check that there's not an include there. So 1, 2, 3 marks. Maybe this one would have been 4 because there was a little bit more work to be done, but there are other methods as well where you don't have to do this, then your graph looks a little bit different. I'm not going to go into that with you. I want to teach you one technique. Okay, usually these are like 3 marks or maybe 4 mark sums. Alright, more examples. Already done. Get 0, done. Factorize, done. Just maybe put some brackets around it so you can better see it. How many factors? 3. Are these factors okay?
Yes.
Yes. They in descending order?
And they positive.
And they're positive. But there's one thing we haven't seen yet. No, they are the same. The last thing that I haven't spoken to you about is if there's a factor that repeats itself, there's 2 of them, the graph is going to bounce. So now, first of all, on your number line, can you give me the critical values? -2 and +3. But -2 I'm seeing is double there, so I know, whoopsie, it's got to bounce there. I'm going to do my graphy thingy, but it's going to bounce there. I've got to know that it's going to bounce there. And add 3. So we'll still go and start on the top, right, go through, don't go through. It's like those video games where the things bounce against the stuff. When you get here, boom. Because it's a bounce, because it's one factor that repeats. It's all about cubic graphs, and next year you'll see, oh yes, I remember that now. But it's just a technique to get you to the answers. Alright, going up to infinity and infinity, where do I colour in? At the bottom, because this is for smaller than. So the bottom is where? From -2, there, and there as well. Right? And include and exclude? Exclude. Because it says so. If it was include, could I include the 3? No. Even if it was include, you don't include the 3 because it's going to be undefined there. So now this representation, how do I write down the answer? X is
Negative.
Smaller than negative 2. This piece, or x is between. You see that method? Always between negative 2 and 3. And I'm done. And I'm done. Now, variations, because I always like variations. Couldn't I have said, listen man, it's everything smaller than 3, but it doesn't have to be negative 2. Think about it. That's what there is on that graph. Everything smaller than 3, but just not negative 2. Interesting? But if I can make your brainwash process here again, put it in little pieces and don't get confused. Okay, alternative method. The actual things I'm aiming towards that you get in a matric paper, you're going to say, but then why must I do all this stuff? There are little pieces somewhere that you're going to use it. Okay. If they ask it in your paper 1, question 1, where all of the equations are there, with the roots, with the formula, with the K method, with exponents, with everything, and boom, here it is as well. Because all I'm saying is solve for x. Whether it's an equation or an inequality, I now want you to remember, if it's inequality, what should be going through your mind? Something about that sketchy thingy. First get 0 to the one side, okay, fantastic, but the other side has to be factorized, but you've been doing that like forever now. So you've got to go to your calculator and you've got to go factorize, or you've got to go do it with your James Bond, all of these methods, and to get to plus 1, the answer is x minus 1 and x plus 2. I'm just doing it quickly. So now it's done. So there will be an extra mark for factorizing. But then on your sketch, what do you need to go sketch? Your critical values are?
Negative 2 and 1.
But there's only 2 now. But then you'll just start top right and it won't come back. Because this is a parabola. This is a parabola. You see it? Where do you color in? At the top. Or long enough. And bigger than means exclude. So representation x is smaller than negative 2 or x is bigger than 1. Then try and do this one for me. There is a snag to it because you're going to have to divide by a negative. Get the factors, do the sum, it's going to take you 2 minutes.